Hello, and we are studying today a question that is on B1 biology. It's specifically on the transport of materials or the movement of materials. This question is going to be exploring about osmosis and a 6-mark question on diffusion. There's some key skills with graphs, so let's get into it, shall we? This first table that you're looking at here says the table below shows the results. It's got concentration of sugar, mass of potato to start in grams, mass of the potato after 24 hours, and the change. So they've minused the start and the final to get an overall change. I can see this is about potatoes. I can see this is about osmosis. So this should be ringing alarm bells in our heads because it's about our osmosis required practical. Remembering that although this one's on potatoes, it could be any vegetable or any plant that they use for this practical. So it says for question B, explain. And that command word, explain, means use your knowledge. We're not describing the result. That's a completely different command word. We're explaining why these results have happened. Explain why the potato in 0.0 sugar solution increased in mass. So we need to explain why this has happened. So the first thing we need to say is it's an increase. It's gone up by 2.20. And we need to explain that by saying it has gained water. Okay, so we first of all write for our first bullet point that the potato has gained water. Okay, but how has it got there? It's got there via osmosis. So we say the water has moved via osmosis. Okay, now we know the general definition for osmosis is it moves from a high concentration to a low concentration, and we need to identify where those concentrations are. So it moves from the concentration of water outside the potato is greater, so that's where the higher concentration is, than inside the cells in the potato, and that's where the low concentration is. Okay, so it's moving from high concentration to low concentration. If you just want to be specific and not go through all that, you could have wrote high concentration in water moves to low concentration in cells in the potato. Okay, you could write it either way. Next question. Question C. Oh, you can see a graph. So these are scientific skills that we need to know. It says complete the graph below. Some of the results have been plotted for you. So they've plotted 0.5 for me. They've plotted 0.4, 0.3. They just haven't plotted 0.2 or 0.1. So I need to go back up to my table, find 0.2. which is 0.25, find 0.1, which is 1.5, and 0.0, which is 2.20. And I need to plot these correctly. And I can see they've done it with a cross. So I know this is not the same as a piece of paper, but I'll get myself a little cross. Just find which symbol. Ooh, yeah, it's not working today. Can anyone see the cross? Where are you? Where are you? Where's the cross? I'm going to use this one. Okay, so make it a bit bigger, then go a bit excellent, make it a bit bigger, then I'm going to make it look a bit of DIY here. Okay, so 0.2 was, if I remember rightly, 0.25, because these are our figures here. If I highlight them for us, so we know what we're plotting in green, we're doing 0.25 because that's the change. It says change in mass. So let's find where 0.25 is. We can see that's 0.2, halfway between 2 and, oh, sorry, it's a bit lower than that. 0, got 1, this is going to be 0.5, so halfway is just between these two lines here. Okay, let's do 0.1. 0.1 is 1.15. So this one's going a bit higher. Each one is going to be worth 1. So 1.1. And then in the middle for 1.15 is just here. And then the last one was 0.0, which was 2.20. So I'll go all the way up to 2 lines above, just there. Excellent. But it says plot the data from the table. Done that. Draw a line of best fit. Okay. So when you draw a line of best fit, you need to try and get your line through as many plots as possible. Okay. So I've got my line, and I can see there's 5 points, but I need to get through as many as possible. Okay. So I'm going to go for here because I've got it through 2, and there's 2 either side. Okay. Then it says the mass of the potato does not change when the concentration of the solution equals the concentration of the outside. Determine the sugar. So you want the osmotic point. The osmotic point is on this 0. So you're looking for where this line crosses the 0, and it's crossing here, which is at 0.25. That's the osmotic point. That is where the particles are even both sides of the material. So I just write here 0.25. Oh gosh, not 35, 25. And what I'll do for you is I'll put a little circle just to show you so you can see what I'm going on about. It's just here where that line of the best fit crosses the x-axis. Okay. Next one says calculate the change in mass for the potato in 0.2 mole sugar solution. Use the table below. So here is 0.2. Okay. It says use this calculation. It says percentage change is change in mass over the mass of the potato times by 100. Give your answer to 3 significant figures. That's the math skill that you need to know. Okay. So first of all, what you want to do is you want to do 0.25 divided by 7.96 times by 100. Why do I say that? Because you've got the change in mass divided by the mass of the potato at the start, and I've times it by 100. Okay, that should give you an answer, something along the lines of 3.14070352. That's what it looks like on my calculator, but it's asked for 3 significant figures, so you need 3 significant numbers, so it's only actually going to be 3.14, and that should be my answer. Okay, last question is a 6-mark question. Okay, this says, in this question, you'll be assessed using your English, organising information, and using specialist terms where appropriate. Diffusion. So this is another method of movement of particles, okay? We've had osmosis, now we're looking at diffusion. Diffusion's got a very similar definition of osmosis, where it's movement of particles from a high concentration to a low concentration. They are both passive processes, which means they need no energy, but diffusion can happen in liquids and gases. We know osmosis only happens in water. Okay, so the movement of many substances into and out of the cells occurs by diffusion. Describe. Describe means say what you see. You're not explaining why it happens. You're saying where and when you can see it. Why diffusion is important to animals and plants. In your answer, you should refer to animals, plants, and examples. Okay, so if this was me, I would want to make sure I've got an example of animals and plants. So I would have divided the answer into 2 straight away. So I would have wrote animals as a subheading and plants, so that I don't become distracted and go off the point. Okay, so for animals, I know, for example, the most important example I've learned about was in the lungs. That's in my head, where we exchange oxygen and carbon dioxide. I know what happens in the digestive system, where we're trading glucose and amino acids. I know in a plant, it happens in the leaves where we trade gases, and I know what happens in the roots where it trades water and ions. But first of all, what is the most important thing? What, if you're asking me about diffusion, what do you need to know? You need to know the definition of it. So first of all, the start of my question will be the definition, just to make sure the examiner knows for 100% that I know what I'm going on about. Diffusion is the movement, oh gosh, if I could spell that would help, of particles from a low, why aren't you telling me off? From a high concentration to a low concentration, okay? It is a passive process which requires no energy I'm recording. Out we go quick. Yeah, of course. It requires no energy and it's a passive process which requires no energy and can occur in liquids and gases. Okay, so I've let the examiner know I know exactly what diffusion is. Okay, I'm also going to say that it takes substances in for use of cell processes. Okay, and products from cells will be removed. So this is an example of how it's going to happen in plant animals. It'll take substances in and remove it. Now, for animals, the example would be gas exchange. It would take in oxygen and remove carbon dioxide from the alveoli. That happens. I'm describing how I can see that happening. There is gas. I'm going to write it same again for plants. Gas exchange for plants via photosynthesis in chloroplasts of leaves. Now these do the opposite, don't they? They take in carbon dioxide and remove oxygen. Okay, so there's two examples straight away. We've got in here via the digestive system, the large intestine absorbs. Oh my gosh, I can't spell today, I'm really sorry. Absorbs water, and we know in the plant that the root hair cells in the roots absorb water and ions for the plants. So straight away,